Hi, everyone. Thanks for joining us today, especially given how many awesome talks are happening at this very moment. I'm Anna, and accompanied by Sarah, and we'll introduce ourselves in more detail soon, but in short, we both have been in software development for over a decade and have been through numerous interviews, both on interviewer side and also as a candidates. And today we will perform 2 live interviews for Flutter developer roles. I will interview Sarah for a junior Flutter developer position, even though Sarah is now junior in Flutter. And then she will interview me for a senior Flutter developer position.
Right, but before we begin, let's talk a little bit about technical interviews in a broader context. This means that the interview will not directly cover behavioral concepts like what's your greatest weakness, and this kind of thing will usually be covered in a separate interview. However, behavioral indicators such as how well you communicate and express your ideas will always be in the back of the interviewer's mind. It's also important to know that the format of the interview is variable. It may be somewhat different from what you see today because often companies will do whiteboard exercises or live coding or walking through a project, in addition to a theoretical part, which is what you'll see today. So the purpose of this talk is to give you confidence and demystify at least this kind of interview format. Finally, let me tell you about this adorable duck. We just want to make it clear who is being interviewed and who is the interviewer. So the interviewer gets the duck. So now I'm going to give it to Anna, who will interview me for a junior role.
Thank you. Hi, welcome. It's good to see you here at the Fullmer Apps agency. Why don't we start by introducing you?
Thank you. I am really excited to be here. I have experience for about 2 years as a mobile tester, and then I graduated to being a native Android developer. And then I discovered Flutter. And I was a Flutter developer for about 18 months before I took a left turn and decided to try community management for a year. And then I had a baby, and I've been out of Flutter for 2 years. And unfortunately, my skills have rusted a little bit. However, because of my experience, I believe that I am not a true junior and I could level up more quickly. And I also feel like a lot of my skills have come back in some hobby projects I've been doing recently. So because of all that, anyways, I feel more comfortable applying for a junior position right now. Shameless plug. All of this is true. I'm looking for a job.
Nice. Let's get into some more technical questions. What was the latest Flutter project you were working on?
Well, as I said, after taking a break from Flutter for a while, I thought that I should do some hobby projects to get back into things. So I decided my most recent one, I did a few. My most recent one was a clone of a weather app in Norway that's very popular called Ear. I chose this because they have an open API and I could compare my implementation of the data to theirs easily.
And what were the challenges there?
The main challenge was getting back into Flutter after a long break, if I'm honest. My computer science fundamentals and general mobile development experience, as well as basic Flutter concepts, were still in place in my brain, but the more Flutter-specific details and muscle memory had kind of disappeared. Furthermore, the framework itself has evolved a lot in the last couple of years, along with the surrounding package ecosystem. So in addition to refreshing, there's also been a lot of learning of new things as well.
That sounds like a lot. What were the things you're most proud of in your weather app?
Well, I'm most proud of how I ended up visualizing the data. In the Ear app, you can see a temperature forecast on a panable x-axis that very clearly shows the temperature changes over time. I didn't want to reinvent the wheel, so I researched existing data visualization packages, and there are a lot of really nice ones out there, but I didn't find any that quite did what I want. I couldn't find one that let me pan through, so the data in these packages made it look really cramped. So I made my own way to create a panable chart and add some little icons so you could see over time more clearly if it was sunny or rainy in the next few hours.
Nice, nice. So getting deeper into technical topics, can you tell me how Flutter is different from other multi-platform SDKs?
Yeah, Flutter compiles directly to machine code using a platform-specific embedder. So this gives access to the underlying operating system and then access to services like surface rendering and event loops. And then using these powers, Flutter can render the apps by painting the pixels on the blank canvas of the given platform. So in other words, Flutter apps are compiled directly to machine code or JavaScript if on the web. And this is in contrast to, say, React Native, where there's an intermediate bridge step between the JavaScript of the React Native code and the underlying SDK.
Mm-hmm. So in Flutter, we say everything is a widget. Can you tell me what is a widget and maybe what are common types of widgets?
Of course. So your UI is declared, is composed declaratively using widgets. So a widget can be anything from the whole screen down to a teeny tiny little checkbox. So we can call them nestable units of composition, I would say. And there are 3 different main types. There's stateless, stateful, and inherited. I should note for completeness that there are other types, but they're rarely used. But they exist if you need them.
Mm-hmm. So can you tell me more about these different common types you mentioned?
Sure. So stateless widgets only depend on their initial inputs, such as static text. A stateful widget is also immutable, actually, but it has an internal state which can change and triggers a rebuild of the widget whenever that state changes, such as when you call setState. And these are the most common types, stateless and stateful, but there's also inherited widget. And so if you put inherited widget in a tree, you can access the fields in that widget from anywhere of its descendants down the tree.
And why exactly you would need that?
Well, when your app and widget tree gets more complex and there's a piece of information you want to get from a top level widget way down the tree of a great-great-grandchild widget, you would have to pass that information through all the constructors down the tree unless you use inherited widget, or something that uses inherited widget to allow you to access the data higher up in the tree.
Mm-hmm. And what are some common built-in inherited widget examples?
The theme widget is very common is a common inherited widget used for material apps and media query.
Mm-hmm. And if you wanted to make your own inherited widget, how would you do it?
You would just you'd make a class and extend inherited widget, and then the child and grandchild, etc. widgets can access all the fields in this class. The default syntax for that is a little cumbersome, though. So it's actually a convention to create a static of method to access the fields in the class. And so that's why you often see theme.ofContext.
Mm-hmm. So you mentioned build context several times. Can you tell me what it is?
Yeah, so all the 3 widget types I mentioned before, stateful, stateless, and inherited, they take build context as an input. And this helps the widget know where it is in the widget tree.
And how exactly does a build context tell the widget where it is in the widget tree?
Right, so a widget doesn't actually contain information about where it is. You could make a widget and put it anywhere. So then this is where the build context comes in. The different widget types I talked about earlier extend a class called widget, which has a method called created_element. And this element is what actually keeps track of the parent and children and where it is in the tree. And an element is actually a type of build context. So when you use a build context in a widget's build method, it tells the widget where it is in the tree.
Thank you. Moving on, what are the common layout widgets you have used?
There's center and container, row, column, stack. And if I had a long list, I'd want to use list view.
All right, so imagine you need to leave an empty space between widgets, for example, in a list view. How would you do this?
There's a couple different ways. You could put a padding widget around the list item, or you could simply put a size box between the items.
So not container. Why?
Container is a kind of convenience widget that lets you do a lot of things to its child. You can set the size, you can set the alignment, you can give detailed decorations like the background color or the border radius. But if you don't care about that, then it's better to use a size box because that is const and then more efficient.
So you said it's const, and what is it?
It's just a keyword that indicates the thing it modifies is a compile time constant. And this means it's only created once and it's more efficient at runtime. However, a const variable can never change, so it's a little limited in its use cases like size box.
Right. Now let's talk about asynchronous programming. How do you use async and await keywords?
Okay. The async and await keywords are used to make asynchronous code easier to read. You can do the exact same thing using the Futures API, but a lot of people don't like that flow, so they prefer using the async await keywords instead. So to use them, when you create an asynchronous method, you would put the async keyword before your curly bracket, and you would make sure that the return type was a future of the type you wanted to return. And then inside the method, you would use the await keyword before the task you want to await for. So let's say, for example, you wanted to fetch some JSON over the network and then do something to it and then return a processed string. So you would put the await keyword before fetching the data, and then the processing of the data wouldn't happen until that was returned. And then eventually you could return the string of a type future of whatever it is you wanted to do to it. Let's see. To handle errors, you would use try catch finally, because as we know, often there are errors when fetching data.
So you've talked a few times about futures. Can you tell me more about them and how they differ from streams?
Yeah, sure. So you use futures to get a single value in the future. But if you wanted to return multiple values over time, that is when you would want to use a stream. So for example, if you were trying to get a file, if you wanted to get the whole file at once, you would use a future. But if you wanted to get it line by line, then you would want to use a stream. Let's see. It's also common to use transforming functions like map and where on the values yielded by the stream. And with futures and streams, you usually use an existing library to do the common tasks like file I/O, but if you really wanted to make your own stream, you could use a stream controller. And then another significant difference is that you have to subscribe to streams in order to get the values yielded by it. And you can only have one listener for regular streams, but actually if you have a broadcast stream, you can have multiple listeners. What else? Oh, yes. Finally, you want to close your streams or else you might get some memory leaks.
All right. Cool, thanks. Let's talk about tests. What kind of tests are there in Flutter framework?
Well, like most other frameworks, Flutter offers support for unit and integration tests. However, because of Flutter's use of widgets and pixel rendering, there are also widgets tests and so-called golden tests.
Okay, let's discuss this topic in more details.
Okay, sure. Unit tests are used to test a single function and verify its logical correctness. In this case, the external dependencies are mocked out. They're important, but they're really limited in their usefulness because they don't tell you how these different units interact with each other. So this is where integration tests come in. An integration test, instead of in a mocked environment, you would run in an emulator or actual device, and you would be testing the app or at least a large part of it. And this would tell you more about how the app works altogether, and you can also test performance.
Mm-hmm. But okay, unit and integration tests, those kinds you would find everywhere. Let's talk about those specific to Flutter.
Sure. So widget tests are used to test widgets in isolation. You can kind of think of like a widget test as parallel to unit tests. They have a special test environment where you pump the widget into it, and then you can find the widget and make sure that it matches what you expect. Like unit tests, this is important, but also limited in its usefulness. So that's where golden tests come in. Instead of testing widgets in a test environment, golden tests match against a golden or verified screenshot. So this is helpful, for example, when you want to test things like, is there enough contrast, or do your widgets align, or are there certain parts that are properly emphasized? And then they're also useful for when you're using custom painter. These kind of things are impossible to test with a regular widget test. So by using golden tests, you can validate and iterate more quickly through the visual changes in your app with confidence.
Okay, thank you so much. Due to the time constraints, we have to end this interview. Hopefully you got an idea of what can be expected from the junior at the Flutter developer interview. They are expected to know the basics of the framework they are working on and show interest in the internals of the things they are working on a daily basis, as well as knowing approaches to automated testing. Additional topics that can be expected during a junior Flutter developer interview include widget keys, packages and plugins, animations, navigation, new Dart language features, also broader concepts like solid, object-oriented programming, dry, and other concepts can be touched.
Okay, now it's my turn. Come on, give me the duck.
Gosh, I'm getting nervous.
Hi, welcome to Fullmer Apps Agency. I'm Sarah. I'm the tech lead of the team you'll be joining. Why don't you start by telling us about yourself?
Sure. Yeah. Glad to be here. Thanks for inviting me. I'm Anna, mobile development expert, passionate about quality software from Ukraine. I am in software development for over a decade, and I have been focusing on primarily creating mobile applications with cross-platform frameworks like Xamarin and Flutter. I work with Flutter since the first stable release, which makes it over the 4 years now. And I am also a Google developer expert in Dart and Flutter, and I talk and blog about the framework on a regular basis.
Wow. Can you tell me a little bit about your most recent Flutter project?
Of course. I currently work as a senior staff engineer in the UK company called Tide. At Tide, we built a financial platform for small and medium businesses, and I'm a part of a team of over 40 Flutter engineers who create a mobile application for our platform.
Wow, that's a really big team. Can you tell me about the challenges you had to overcome in this position?
Oh, sure. It's indeed quite a challenging project. Given the scale of the team and the product we are building, the code base has to have a solid foundation, an architecture that is scalable and maintainable enough to support the countless features we are creating on a daily basis. And we have to be consistently aligned on the approaches we take to solving typical tasks like dependency injection, navigation, localization, design system, and many more.
I see. So how did you solve these tasks and what are you most proud of?
We have built a modular architecture, which we like to call Lego architecture. And shameless plug to remind you about the talk I did with my husband Alexander last year at FlutterCon conference, which is called Lego architecture. So we took a package by feature approach where each feature is isolated in its own package and exposes only a few connection points that allows to plug it into the overall project architecture. And we also use code generation extensively.
Oh, interesting. Can you tell me a bit more about how you use code generation?
Gladly, I actually quite enjoy this topic, and another shameless plug to remind you about the Fun with Code Generation talk I did last year at FlutterCon conference. So because of the challenges we have, like staying consistent across the project, and also we had to deliver fast, we are using two types of code generation. First, we created Mason templates to generate feature packages. With a single command line, we create a lot of boilerplate code that arranges navigation, localization, dependency injection, API communication layer, state management, and even tests. And second is, of course, code generation with build runner. We use it a lot for almost all tasks I just mentioned, so freeze, JSON serializable, retrofit, auto-route, and BDD widget tests, and few other packages. And it significantly reduced the time we spent on implementing each feature and also removed the potential for errors due to this monotonous work. So as you see, I'm a big supporter of using code generation, but of course it comes at a cost of having additional dependencies, and not always one of them can be updated without another. And also generated files have the most merge conflicts if they are added to the code base.
Sounds tough. You've mentioned in your career that you were primarily focusing on mobile applications. Can you tell me about some universally applicable recommendations for developing a high-quality mobile project? What would you pay attention to?
Well, that's quite a big question. I would probably break it down into several major parts. First being the actual development. So the project has to have a solid architecture that gives unambiguous and consistent answers to most of the questions developers face when implementing their features, like state management, navigation approach, localization, the way we organize design system, the way we do error handling, how we do analytics, monitoring, how we approach the application accessibility, a set of linters to apply, and so on. So, and I would also add the testing strategy to this list. Another major part to name is processes and automation. So basically anything related to CI/CD, starting from what tools to use, what branching strategy to follow, what kind of checks to perform with each PR or after each change to the main branch. And also release strategy, how to deliver the final application, probably first to internal testers, but then also to end users. I would also name knowledge sharing as an important part, because all developers in the team, regardless of its size, need to be aligned on the approaches they take across the code base and also have shared knowledge about the domain and the requirements.
You've mentioned a lot of interesting topics there. One of them was testing strategy. Can you tell me a little more about that?
Sure, I think that a well thought through testing strategy should give answers to questions like how, when, and by whom the application is tested.
And how would you answer those questions?
It, of course, depends on the size of the project and the nature of it. But by default, I would say all parties would benefit if the problems are detected as early as possible. That's why I think it's developers' responsibility to continuously use and test the application and the features they are creating. and be responsible for its quality. They can, of course, be backed up by the team of QA engineers in case the company has enough budget. But I'd like to emphasize that the product quality is, first of all, developers' responsibility. And clearly, manual repetitive testing is not the most efficient way to test the application. So in theory, it shouldn't even exist in the world of front-end development. However, it's a bit hard to achieve. So developers would be creating various kinds of tests they cannot run automatically and frequently.
Okay, so what type of test would you recommend for that?
There is such thing as testing pyramid. And there we have unit tests covering the major part of the functionality and end-to-end integration tests taking only a small part of the top. And we know that Flutter documentation names 3 types of tests: unit, widget, and integration. So I would say that unit and widget tests, and probably golden tests here, correspond to the unit tests from the testing pyramid, because basically they only differ by the definition of what is a unit. They are fast, atomic, low maintenance, and should be used as much as possible to ensure the correctness of the implementation of different parts of the application. And what is called integration tests in Flutter correspond to end-to-end testing in the testing pyramid. Because it's when we run the entire application with tools like Petrol or Maestro or vanilla Flutter integration tests, and we can test how the application interacts with backend or with native platform. And these tests require more maintenance, like a lot more maintenance, and are also slow, but they provide the highest level of confidence about the application quality. So there is a trade-off of having fewer of them compared to unit tests.
Okay, so we've discussed who and how should we implement these tests. And the question is when to run them.
Right. So as I mentioned, unit tests are supposed to be fast. Of course, if they form the majority of a project test, and depending on the project size, it still may take significant time. But anyways, I would say they should be run as frequently as possible. First of all, locally on developers' machines. Ideally, it should be possible to run them in watch mode, and so we would see problematic or untested code in real time. And they should also be run with each pull request or after each change to the main branch. As to integration tests, ideally we would also want to run them as frequently as possible, but because they are much slower, daily runs or runs before making a build can be a good compromise.
It's nice that you've mentioned several different kinds of automation. I hear daily integration tests, and you've also mentioned pull request checks. What other things do you think should be automated?
Automation is quite a big topic, and many things can be mentioned here. Let's start with local development environment. I would say even such small things as turning on the auto format on save in the IDE can be a good decision to speed up the developers and keep the code base consistent. Also, such things as Git hooks can, for example, attach a Jira ticket number to each commit or automatically format all the changed files. And I think I can also mention Mason tool here, which would create a lot of boilerplate code out of a template. But clearly, most of automation happens on CI. Let's take the setup for every pull request as something we do quite regularly. The checks can be done with each PR include running analyzer to ensure there are no linter warnings. It can be, again, formatting changed files and running tests, of course. Depending on the size of the project, tests can be run for the entire project only or only for changed packages. Oftentimes, teams may have custom agreements about coding style, so this can also be validated with fine-grained scripts or existing solutions like GitHub Actions or the Danger tool. Another quite regular activity that can be automated is upgrading dependencies. Flutter version and packages on pubdev get updates quite often, and this task can be run daily or weekly. The script would raise the version of one or several dependencies, run, for example, unit and integration tests to make sure that the application still runs and works the same way, and would raise APR. And if you're using GitHub, there is a dependabot tool that can help with that. And let's not forget about release automation. The must-have requirement for me is not being able to upload the builds created from local dev environment into the distribution channels. And on CI, the automation strategy is typically tightly coupled to the application flavors and also team agreements. But typically, there are at least two types of builds: development builds and release candidates. But overall, I'd recommend and try to automate as many things as possible as early as possible.
I'd love to talk more about release strategy, but unfortunately, we're a bit limited on time, so we have to move on. On a scale of using existing packages and solutions to creating custom fine-grained solutions, where do you stand?
That's quite a good question. I would probably say I lean towards using existing solutions and customizing them to the needs of your project. But of course, everything is individual and every dependency has to be evaluated properly.
So when you need to solve a particular problem, how exactly do you evaluate the dependency and pick it?
There are several things to pay attention to. The first and most obvious is, of course, the package popularity. The more users test it in production, the better is its quality, and it's more likely to get contributions from the community that uses it. But it's not the only criteria to pay attention to. I also check when the package was last updated and if it gets regular updates. I would also check dependencies of this package because they will become dependencies of my project as well. And staying on the pub.dev side, I would also check the package license and if I'm allowed to use it in my project. Now, moving on to the project repository, I would look for a few pieces of additional information. If the package has tests, if it has documentation and the proper README file, and if the code is clear enough so that I would be able to contribute in case there are any issues. And finally, I check the list of open and closed issues and merge requests to evaluate how well it is maintained and how fast things can get resolved.
Yes. So if you discover some issue with your dependency, how would you deal with this?
Well, first of all, unless it is a package that is rooted deeply into the project architecture, like state management, I would probably have it abstracted behind the facade, so I'm not tightly coupled with the implementation and the package can easily be swapped out with another solution. But if I feel like I can find a solution to the issue, I would go to the repository, fork it, and open a PR. And meanwhile, depending on the issue severity, I might switch to my own fork.
What if you made a PR in the original repository and it wasn't merged?
In most cases, I would just keep using my GitHub version. There are also examples in the community when such forks became the mature solutions of their own, like DOX.
So what are the different ways to make a reference to a package?
So I have already mentioned hosted solutions like pubdev and GitHub. And there are also services for hosting your packages privately, which makes the remaining way to reference the packages by putting it just next to your project and reference it by path.
So you mean monorepo?
Yeah, exactly.
And what is your experience with that?
So far, the advantages of using it, like being able to use the latest version of the package without the need to open multiple PRs and multiple repositories, outweighs the downsides, like not being able to reuse it in a different project in a different repository.
Once again, it's been a pleasure interviewing you, Anna, but we have to end this session. Hopefully, you've gotten an idea of what kind of interview you can expect for a junior or senior. And even though it may include the same questions just asked in the previous interviews, there's also a chance of questions requiring a much deeper understanding, like slivers, threads, isolates, tree shaking, and overall mobile development best practices, including security, accessibility, release strategy, collecting code metrics, and so on. Many of these questions have more than one correct answer, and some of them are controversial. So during a senior position interview, we evaluate not only your deep understanding of the Flutter framework, but also the overall engineering expertise and how well you defend your choices.
Okay, now we'd like to spend a few moments on additional thoughts around the interview process in general. First of all, in the end of the interview, there should be a time for candidate questions. And you don't want to miss the opportunity to ask questions from the technical person, from your future team. It can range from why do you like working at this company to deeper details about the project architecture. But try not to go over time. For the interviewer, it is just another meeting in their working day, and they most likely have other things to get back to right after. So what to do after the interview? If you got accepted, congrats. If you were rejected, ask for the feedback. Asking for a feedback during the interview may not be the best idea because, first of all, most probably it will not be very well thought through, and also it will probably go over time. And unfortunately, it's not guaranteed that you'll receive a feedback after the interview nowadays. Still, don't think it says much about you or your Flutter knowledge, because passing the interview on its own takes a little bit different set of skills than what it takes to be a great Flutter developer. And also, the company just may not have the budget to meet your expectations at this time.
So, yeah. Although we tried to show how a typical Flutter interview could go, there are many more topics that we did not have time to cover. So we've prepared a list of resources to help you prepare for your next interview, either as an interviewer or interviewee, and help enrich your overall knowledge, including the conference talks that Anna mentioned earlier. So please use this QR code at your convenience.
And thank you so much for joining us today. Since it's the last session of the day, we don't want to take any more of your time, and we can answer questions individually off stage. Thank you.
Thank you.